Okay, so FOIL. F-O-I-L. What does the F stand for?
First.
First. O?
Outside.
Outside. I?
Inside.
Inside. And L?
Last.
Last. Okay. And when we FOIL, the most important thing is just to remember, because this happens a lot, make sure what operation is happening when you're FOILing. So when I say first, and what am I doing here? What operation?
Multiplication.
Multiplication, okay? So remember, we're multiplying, and then after all the multiplication, we can combine like terms. So starting with the firsts, so that's 2h, negative 2h, and positive 9h, what do I get? Negative 2h and 9h. I know some of y'all got it right already. You
Negative
know.
18.
Negative 18. And then what about the h?
18h squared.
Squared, good. Okay, I've got h times h, that's h to the power of 1 times h to the power of 1. So together I get h to the power of 2. So that's my first. Now I do the outside. Outside is like a sandwich, the buns of the sandwich. So the outside terms go next. Let me move this down a little bit. Okay. What do I get here? Negative 2h times negative 2.
What's the question, Miss Noel? I mean, Miss Lopez, I'm sorry.
Just doing the next multiplication, negative 2h times negative 2.
Positive 4.
Positive. So I'm adding a plus sign. Positive 4h. My h comes along for the ride. Inside. 9 times 9h.
81.
Positive or negative?
Positive.
Positive. And then last but not least, 9 times negative 2.
Negative 18.
Negative 18. All right. Now I'm combining like terms. What are my like terms?
4h and 81h.
Perfect. What's 4 plus 81?
85.
85. So I have negative 18h squared plus 85h minus 18. All right. Now, anybody who was having trouble with it before, go ahead and take about 1 minute to work on number 2. And if you can try number 3 as well, and then we'll go over it all together. So 1 more minute, and then we'll go through it. All right, about 15 more seconds. Okay, let's do number 2. Now I want to hear more participation. Don't be shy. I already know like 4 or 5 people who got it completely right because I was looking at the chat. So if you know the answer, don't be afraid. Put it on public or say it out loud. I want to hear you. I want to see you. So number 2, first. 9h times negative h. What do I get?
Negative 9h squared.
Negative 9h squared. Now I know a lot of you, I know who got it right already, so you don't have to tell me on private. Put it on public. Ijara's been participating. I want to hear from more people. I'm gonna move this over. Okay. Negative 9h squared. Now outside, 9h times negative 1. What do I get? 9h times negative 1. Put it on public. Chris, you got it. Put it on public.
Negative 9h.
Negative 9h. Good. Good. Inside, 3 times negative h.
Negative 3h.
Negative 3h. Good. And then finally, 3 times negative 1.
Negative 3.
Negative 3. Lots of negatives here, so we're going to be very careful with them. When we combine like terms, negative 9 and negative 3. What do I get? Good, Raymond, negative 12. So I got negative 9h squared minus 12h minus 3. Any questions on number 1 or number 2? What type of polynomials do I have here for both of them?
Trinomial.
Trinomials. What is the leading coefficient of number 1?
Negative 18.
Negative 18. And the leading coefficient of number 2?
Negative 9.
Negative 9. Beautiful. All right. Last one, I'm going to erase this because we already know what it stands for. And let's do a speed round on this one. Shout it out when you know the answer. 5 times W.
5w.
5 times 4.
20.
W times W.
W squared.
W times 4.
4w.
Good. Okay. Now this one's in a different order than all the other ones, so we're going to be careful when we combine like terms. What are my like terms?
5w and 4w.
5W and 4W. So in total, 5 plus 4, I get
9.
9W plus 20 plus W squared. But is this in standard form?
Nope.
No, what's the correct order that I should write this in?
W squared plus NW plus 20.
There we go. So again, remember, standard form goes from the highest exponent down, decreasing order. So the square comes first. The square goes in the front. Leading coefficient in that case, what is it?
1.
1. You don't see it, but it is there. It's a 1. Questions on these 3? Questions on foiling?
I did a different strategy. I didn't like the arrows because they get all over the place, so I just broke it down. For example, I did first, second, third, and fourth. For first, I did 5 times W, second, 5 times 4, third, W times W, and fourth, W times 4. And that's how I got my answer.
And then you kind of put them all together afterwards?
Mhm.
Yeah, if that works for you, that's another great way to do it. You just the most important thing, I would say there's two most important things. One is stay organized. So whichever way you do it, just stay organized so that you make sure that you get that you hit every combination, right? So you just want to make sure that you're hitting each combination. And number two most important thing is just to watch out for all the positives and all the negatives, and make sure that when you're multiplying, you think about it, if it's a positive times a negative or a negative times a negative, you come out with the right answer in that case. So any questions? Cool. So like I mentioned yesterday, today we're going to basically keep going with multiplying until we get really, really comfortable with it. And we are going to do a few like slightly more challenging problems, just see how far we can go. So first, right off the bat, I want you guys to try this one on your own. And when you have your answer, put it in the poll for me. So this one is not foiling. What are we doing instead?
Distributed.
We're just distributing. So this one's slightly easier, you can say. But you still have to be very careful. Take it easy. Be very neat. See what you get. Okay, give it 30 more seconds. I see 6 students have responded. That's about half the class. 30 more seconds for anyone who has not put their answer in the poll. Good, guys. 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right. Let's take a look. Very interesting. This is exactly what I expected. So the majority of people chose answer choice C, but I had a couple people choosing answer choice B. So what that tells me is that we have to just review really quickly what we do with those exponents. So let's take a look. All right, I have 5y, but that y has an exponent technically. What is the exponent on this y out in the front?
1.
Yeah, it has an invisible 1. And what do we do to the exponents when we multiply?
Add.
We add them. So the first pair of numbers, I'm doing 5y times y to the power of 4. I'm going to get 5y to the power, I'm adding, 1 plus 4 gives me 5. So that's one of the biggest like little mistakes that people make, is forgetting to add, especially when you have an invisible 1. So what I always do with these types of problems, if you chose answer choice B, it will be very helpful for you to draw the invisible 1 just to remind yourself that it's there. Because sometimes since we don't see it, we forget that it's there. But if you put it in, you're going to remember that you have to add that to the other exponent. So 5, we get 5 because we're adding 1 plus 4. Same thing goes for now the rest of these. So I'm multiplying the coefficients. So 5 times 6, I get 30. But then I'm adding the exponents. So 1 plus 2, I get y to the power of 3. And then finally, again, we're multiplying the coefficients. So 5 times negative 11, I get negative 55. But I still have a y. That y comes along, and I get negative 55y. So that is answer choice C. But I can see from the responses that, if you chose answer choice B, you were really, really close. You just forgot that you have to add those two exponents. So does anybody have any questions on this one? Awesome. All right, let's check out another one. So now, similar idea, I want to keep using these polls because the polls are really, really helpful for me so I can understand what I still need to go over. So don't be shy. I'm not going to share your answers with the class. I want to see an answer from everybody. Go ahead and take a moment. Use the FOIL method, and let's see what we get. Okay, I see about half the class has put in their responses. So I want to take another 30 seconds. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Let's check this one out, guys. So most people chose D. That's awesome. That's awesome. So that is the correct answer. But I do see a few people who chose A. So I definitely want to just clarify how foiling works. So let's take a look. Now, I kind of want to show you a different way to do this problem just because I feel like it's going to help you to understand why we foil. Like, why is foiling so important? So think about this. Usually, let's say you just have a very simple distribution problem like this. When you distribute, you just want to make sure that you distribute the 3 to everything else, right? So we would get 3x plus 12. That is simple distribution. Well, what's happening here, it's kind of like it's like kind of like a double distribution. So you can think about it this way. You can think about it, okay, I have 2x squared, and that has to be multiplied to everything over here. So that would be x plus 4. But then I also have this 3 right here. So it's kind of like I'm doing 2 distribution problems, because on the one hand, I have to distribute the 2x squared, but on the other hand, I also have to distribute the 3. So if you kind of split it up this way, this is just a different way to do the same exact thing. It's like a double distribution. And let's just see if we get the same answer. So 2x squared times x, I get 2x to the power of 3. 2x squared times 4, I get 8x squared. Now over here, 3 times x, I get 3x. And 3 times 4, I get 12. So notice I have the same exact answer. I just did it a slightly different way. Because at the end of the day, what foiling does is it kind of splits it up, and you end up doing 2 separate distribution problems. And Karina thinks this is easier. Well, then if you prefer it this way, then do it this way. You can do it whichever way you want. And if you find that this way is easier for you, 100% do it. Because for me, it's more important that you find your own way that helps you get it right, rather than like struggling to do it my way. I grew up using FOIL. That's the way that I was taught. So I enjoy it. I kind of like it better. But if this works for you, then do it this way instead. Totally up to you. But I'm also going to show how it works with FOIL. Okay, so take one last look. You can write this down. And then I'm going to do the same problem again, but this time I'm going to use FOIL. So take about 15 more seconds. All right. Same problem, same numbers, different strategy. Here we go. Using FOIL instead. Starting with the first, and note it, I'm going to do basically the same thing. So starting with the first, 2x squared times x, I get 2x to the power of 3 because I'm adding the exponents. Outside, 2x squared times 4, I get 8x squared. Inside, 3 times x, I get 3x. And last, 3 times 4 gives me 12. Same answer. I would say that foiling is just kind of a shortcut of what I just did before. So you end up with the same answer, same exact numbers, just 2 slightly different ways to do it. Are there any like terms, by the way?
No.
No like terms. What type of polynomial do I have?
Polynomial.
Just a polynomial. What's the leading coefficient?
2.
Good. What's this called? That 12 right there. It doesn't have an exponent. It doesn't have a variable.
A whole number?
It has a special name. Starts with a C.
Coefficient?
Not a coefficient. Because coefficients go in front of variables. But when you have a number, a whole number, it could be a fraction too, that's just on its own. We got a constant. We got a constant. Just trying to review some vocabulary. So any questions on this one? Cool. All right. Okay, so now I have a word problem. And I know a lot of times you guys see a word problem and it's just, woo, just feels like too much. But let's read it. Let's read it carefully and let's see how we can solve this using what we already know how to do. So who would like to volunteer to read? I have 2 word problems today. Here's the first one. Who would like to start us off? You know, I haven't heard from Juan in a while. Or Shania in a while. Anyone at home?
I'll read.
No read? Okay, go ahead, Ajira.
A paving company is paving the rectangular student parking lot at Hamilton High School. The length of the parking lot can be represented as 5p -7 and the width as 3p plus 4. Which expression represents the area of the parking lot?
Awesome. All right. So I've got the length of the parking lot, and I've got the width of the parking lot, and I want to know the area of the parking lot. Well, what do we know about area of a rectangle? What is the area of a rectangle? Think back.
Length times width.
Yeah, length times width. Oops, length times width. That's area. Okay, think back to Miss Weaver's class or whoever you had in the 6th grade. Length times width, simple, simple. Well, I'm multiplying length times width. And I know that my length is 5p minus 7. And I know that my width, my width is 3p plus 4. And since I have two binomials and I'm multiplying them, what should I do?
Foil.
Yep, we're just gonna FOIL. This is an easy, it's easy in the way that we already know how to do this. So even though it is a word problem, even though it might look more complicated, we're still just doing the same exact thing. We're gonna FOIL. So go ahead, try it out. Here's the poll. And if you had the incorrect answer on the previous one, see if you can get it right this time. All right, so I'm seeing a couple people told me in the chat, and I just realized it myself. There is a typo, I believe, in the answer choices. So if you're not coming up with the right answer, there is a typo. So I'm going to actually pause the poll.
Yeah, I was having difficulty because
Yeah, there is a typo. So if you had a different answer and you don't see it in the answer choices, go ahead and send it to me in the chat. Take about 30 more seconds. Send me your answer if it's different from the one you see in front of you. Good. Yes. Good job, guys. I'm seeing the answers. I should have checked this slide. I apologize. Good job, guys. All right. Awesome. Everybody who just sent me the answer, you guys all had it right. So let's check it out. So let's just see why the answer choices are wrong. I start with first. What do I get? 5p times 3p.
15 p to the
Mhm.
power of 2.
Good. 15p to the power of 2. Outside, 5p times 4.
20p.
20p. Negative 7 times 3.
Negative 21p.
Negative 21p. And then negative 7 times 4.
Negative 28.
Negative 28. Okay, what are my like terms?
20p and 21, negative 21p.
20 and negative 21. And so what is 20 minus 21?
Negative 1p.
Negative 1p. But as we know, we don't write the 1. So it's just minus p minus 28. Which I think answer choice B just made a little typo. That should have just been p on its own. But yeah. So any questions on this one? If you got a different answer, take a moment and just make sure, first of all, write it down correctly in your notebook. But also, while you're writing it, think about where you made your little mistake and how you can make sure that you don't repeat that same mistake next time. Any questions? All right, let's take a look at the next one. So the next one is very similar. I'll check it this time to make sure that there's no mistakes, but go ahead and try this one on your own. Okay, this one is fine. So it is one of those answer choices. All right, 30 more seconds. This is looking good, y'all. But I'm still missing 4 people's responses. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Take a look, take a look. So most of you chose the correct response, but again, I still have a few people who are maybe still having a little bit of trouble. So now that I know so many of you know how to do this, I want you to tell me what I got to do.
Put it in
First,
form.
write out the power.
Let's write it out. So, okay, what do I write?
2x minus 6 in parentheses. And then 3x minus 5.
Okay.
Then you multiply 2 times 3. And there's 2x, so it's going to be x to the power of 2.
Mm-hmm.
Then you multiply 2x times 5 times negative 5. It's going to give you negative 10x.
Mm-hmm.
Then you multiply negative 6 times 3, which gives you negative 18x.
Finish it off. Good.
Then negative 6 times negative 5, which equals 30.
Why is that positive 30?
Because a negative times a negative equals a positive.
Good. Awesome. And then we combine like terms.
It's negative 28x.
Awesome, awesome. Good. So I think a couple people might have chosen the wrong answer. If you chose A or C, you probably tried to add those two binomials, but we're not adding because we're looking for the area. We're looking for the area. In what situation would you add rather than multiply?
Perimeter.
Mm-hmm. So think about this. This would be a completely different situation. If you were looking for perimeter, perimeter is when you add every single side, right? So if I have my rectangle, and this is 3x minus 5, and then this is 2x minus 6, well, I have to add all 4 sides. So I would have to add 2 times 3x minus 5 and 2 times 2x minus 6. And when you add them together, I believe you end up with one of these two answers. So you just got to be very careful. Read the question properly and just make sure you know what you're looking for. Area is multiplication. Perimeter is when you add everything up. So any questions on this one? Now, tomorrow, we're going to be doing some like really challenging problems similar to this one, but it takes it up another level. So today I want to make sure that we feel really good about multiplication so that we can move on to some slightly more difficult problems. All right, what's my leading coefficient?
6.
6. Easy. All right, next problem. Okay, let's take a look at this one. This one's a little bit different. I have a binomial and I'm squaring it. Now, what does it mean to square something? If I'm doing something to the power of 2, what am I doing to it?
Multiplying it by itself.
Multiplying it by itself. So in this case, I'm squaring this binomial. So what that actually means is that I'm going to take the binomial and I'm going to multiply it times itself. So this is 3x plus 6 times 3x plus 6 times itself. So again, we're going to be using FOIL, and go ahead and at this point, I want to see 100% correct. I want to see 100. We're getting really close. The last problem, it was like 70%. So we're getting pretty close to 100%. Go ahead and try this one out, and let's see what we get. Okay, I have 6 responses out of 13. So I'm still waiting on about 7 more. All right. Take about 30 more seconds. And 10, 9, 8. Guys, we're at 70% right now. Let's get like one more person to put the right answer. 5, 4, 3, 2, and 1. Oh, it went down in the last second. Okay, we're at 64%, 64%. But here's the thing, I'm actually pretty happy with this response because as long as you didn't put A or B, we're getting there, we're getting there. So C and D are very similar, right? There's only one difference between them. So let's take a look at where that might have, oh, Juan clicked the wrong, okay, Juan, sure. Let's go ahead and see where that issue comes, why is it D and not C? Why is it this? That's where the only difference is. So if I go through it, I'm going to FOIL 3x times 3x. What do I get?
Times 3. 9x squared.
9x squared. 3x times 6.
18x.
18x. 6 times 3x. 6 times 3x.
6 times 3x is 18x.
Oh, 18x again. And then 6 times 6?
36.
36. Good. Okay, well, I have like terms here and they're the same number. So I just have to go ahead and add those up. What's 18 plus 18? Or 18 times 2?
18 times 8, 18 plus 18, 36x.
6x, good. Plus 36. Okay, so what it seems that what happened is that maybe those who chose answer choice C, maybe they forgot to add, Or maybe they forgot to do the I of FOIL. Maybe they skipped one of the steps of foiling. But in any case, we do get answer choice D. Do I have any questions on why it's D and not C? Okay, if you chose C, just make sure you understand. If you have any questions at all, now's your chance to ask. Okay, now, before we move on to the next problem, I do want to go over kind of an interesting thing that happens when you square a binomial. So remember, we started off with a binomial and we were squaring it. Sorry, I just want to make this a little smaller. Okay, it doesn't want to cooperate. There we go. Nope. What is going on? Technology these days. Okay, fine. I'll just leave it. So we started off with a binomial and we were squaring it. And what type of polynomial did I end up with?
Binomial.
My final answer.
Answer, oh, trinomial.
Trinomial. So the answer that I got is a special type of trinomial. It's called a perfect square trinomial. A perfect square trinomial. And let me actually explain what a perfect square trinomial is. So I'm going to take a couple, actually, let me add a little sticky note. Okay, so that we can kind of write down in our notebooks this special type of trinomial. And I see somebody in the chat is asking if it's because of the 36. And yes, that's part of it. So whenever you have a trinomial and you kind of notice something about it, what do you notice about the 36 as well as the 9?
They're in this. It could be, no. The square root of.
Yeah, both of those numbers, the 9 and the 36, are perfect squares. Remember that perfect squares is any number that you can take the square root of. So for example, the number 9 is a perfect square because the square root of 9 is what?
3.
3. The number 36 is a perfect square because what's the square root of 36?
6.
6. So there's a bunch of perfect squares. Most of you, hopefully all of you already have them memorized. 4, 9, 16, 25, 36, 49, 64, and I could keep going. All of those are perfect squares. Well, a perfect square trinomial is when you take a binomial. So let me go ahead and I'm just going to give us a simple binomial, a plus b. And you square it, what you end up getting is a perfect square trinomial. And that perfect square trinomial is just going to be a squared plus 2ab plus b squared. And we're going to see why the answer that we got is a perfect square trinomial. So go ahead and just start by writing down the actual definition, and then we'll kind of explain it a little bit. So if you're a little lost, that's okay, we'll explain it. It's okay if you're lost. I already said we're gonna explain it. Sit in that confusion and it'll all make sense in just a moment. So let's go to our problem, and I'm gonna erase what we did because we did it using FOIL and that gave us the right answer, but I just wanna show you a little shortcut that you can take if you want to. Like I said, anything in this class, if you can find a way to make it work for you and you like it, go for it. If the strategy I give you just confuses you, you don't have to use it. But in our problem, we have 3x and we have a 6. Okay, so you can think about it like the a is 3x and the b is 6. And if I just follow the rule that I just wrote down, if I follow this rule, I'm just going to do exactly what it tells me to do. So it's telling me to take a and square it. So this is 3x, and I'm going to square that. Then I'm going to do 2 times a times b. Well, a is 3x, and b is 6. And then finally, I need to do b squared. Let me move that over. So b is 6, so 6 squared. So again, all I'm doing is following that rule of perfect square trinomials. I'm just putting in the value of a and I'm putting in the value of b and following the rule. Well, let's see what we end up with. What would be 3x to the power of 2?
3x to the power of 2 is
Just
9.
distribute that exponent. We get 9x squared. Then I have 2 times 3 times 6. What's 2 times 3 times 6?
2 times 3 times 6. 2 times 3 is 6x. 2 times 6 is 12.
So 2 times 3 gives me 6, and then I'm multiplying that by 6, so altogether I get 36x. And then finally, 6 to the power of 2, I get 36. So notice I got the same exact answer. Same exact answer. A different way. So again, there's 2 ways to do it. If you like to FOIL, if foiling is your jam and you feel good about it, that's fine. Then you can use it that way. If you like this rule of perfect square trinomials, you can also use it this way. But either way, something you can always do is maybe if you do it one way, try doing it the other way just to double check and just make sure that you get the same answer, because you should get the same answer. So it goes both ways. Like if you want to just check your work really quickly, then try out a different strategy and see if you get the same thing. How do we feel about this? Not bad, not bad. Okay. Any questions on this whole problem? Okay. All right, let's try another one. So here's another, I'm squaring this binomial. So now you guys have 2 different strategies you can use. So you can FOIL, or here, let me copy and paste our little rule over here so we have it on the next slide. So you can use FOIL, or you can use the perfect square trinomial method, or try both. Try both and just see which one works better for you. And I will put up the poll and go ahead. Wow, I have a couple of quick math students who already put down the answer and they both got it right. So good job. Oh no, you put the wrong answer? Okay, so I won't count your response in the final calculation. I have 8 answers in, waiting on 4 more. I'll give you guys 15 more seconds. And 5, 4, 3, 2, and 1. Take a look, guys. 89%, and then the one person who clicked the wrong button by accident doesn't count, so technically everybody got it right, technically. So that's good. Now let's go ahead and go over it. I'm going to do it both ways. I'm going to start by foiling, and then I'll use the perfect square trinomial method, just so you guys can get a look at both options. If only that would, there we go. Okay, starting with FOIL. So I know that I got to split this up because this is x plus 1 times x plus 1, multiplying it by itself. So let's go ahead and take a look. X times x, what do I get?
X squared.
X to the power of 2. X times 1.
X.
Just x. 1 times x.
X.
Another x. 1 times 1.
1.
1. What are my like terms?
X.
The 2 x's. So I have 2 of them. So remember, this is 1 and that's another 1. So in total, I have 2. That's what I got. I got answer choice D. So it was D after all.
Oh, I chose D, but
I think it was someone else who clicked the wrong one.
I felt like it was supposed to be x squared because it's 2 x's.
No, I mean, did you do it with foiling or did you do it the other way?
Foil.
If you feel good about foiling and you can figure it out, and the most important thing, Ajira, is if you aren't really sure about your answer, try the other method and see if you get the same answer. If your answers match in the end, then you know you're good, right? But if they don't, then you can go back and try it again. So that's why sometimes having both methods is actually really useful, because you can use it in order to check your answers. So questions on foiling. All right, now let's try the other way. So if I do it the other way, A is x and B is 1. So following my rule, I'm doing A squared, so that's x squared. Then 2 times A times B, so it's 2 times x times 1. And then I'm doing B squared, so that's 1 squared. Oh no, Karina did it both ways, and that just means you're still learning the method. That's okay. If we're making mistakes at this point, don't be too upset about it, but definitely just make sure that you can practice it. And I know, Karina, I know you already did your homework assignment because you always get it done like super, super early, but you can always go back and do it again, just like as a way to practice it again. Okay, that's always a good idea. Okay, so what do we got? We got x squared. What's 2 times x times 1?
2x?
Yeah, 2x. 2 times 1 is 2. So I get 2x, and then 1 squared is just 1. So I get the same answer doing it the other way as well. How do we feel? Any questions on the perfect square trinomial method or on anything else at this point? We're getting better and better, I can tell, because all the answer choices are getting better and better. So how do we feel? Okay, all right. So we're just going to do one more thing, which is we've done a binomial times a binomial. We've been doing that with foiling. What do I have here? I have a binomial times what?
Trinomial.
Trinomial. Okay, so we're just going to do a couple of these because They're not as common, but it's still definitely necessary to just make sure we know how to do it. So I have a binomial times a trinomial. Well, the best way to do this is to do a method called partial distribution. And what that means is I'm just going to split up the binomial. So let's take a look at what I mean by that. So I have an x and I have a 2, a positive 2. So I'm just going to split it up. I'm going to start with my x and I'm going to distribute it to the trinomial. So again, I'm just taking my x and then I'll take the 2, the positive 2, and I'll distribute that to the trinomial. So basically what I'm doing is I'm kind of splitting up my binomial and treating it as 2 separate distribution problems. So that's why it's called partial distribution, because I'm distributing from the x and then I'm distributing from the 2. And you're going to end up with this super, super long polynomial. So at the very end, probably honestly one of the hardest parts at the end is just making sure that when we combine like terms, we're doing it very, very carefully and very, very organized, because this is where it could get a little bit confusing. So any questions up to this point before I continue? Okay, let's try it. So again, I'm just going to distribute. So x times x squared.
2x squared.
Careful. This is x to the power of 1 times x to the power of 2.
Oh, x to the power of 3.
There you go. Okay, next one. X to the power of 1 times negative 5x.
Times negative 5x.
5 to the power x, 5x to the power of 2.
5x to the power of 2. And careful with my sign.
Negative 5x.
Negative 5x to the power of 2. All right, and then x times 4.
4x.
4x. Then I'm just going to hop on to the next one and just keep it going. 2 times x squared.
2x squared.
2x squared. 2 times negative 5x.
Negative 10x.
And then 2 times 4.
8.
Awesome. All right, so now I've got this really, really long polynomial. So this is where we just got to be super careful when we combine like terms. And when I combine those like terms, I'm just going to try to get it into standard form as well. So if I'm working on standard form, which of these is going to go first?
x3.
X to the power of 3, good. And something that I like to do is I like to cross them off as I go, because when it's super long like this, I just want to make sure I don't lose track of any of those numbers. So I'm just crossing them off as I go. So I got my x to the power of 3. Now, what like terms can I combine?
4x. Negative 10x.
4x and negative 10x. I can do that, but if I want to keep it in standard form, what should I do next?
Negative 5x to the power of 2 and 2x to the power of 2.
Good. Okay, combining like terms, what do I get?
Negative 3x squared.
Negative 3x squared, good. Continuing on, if I want to continue combining like terms, what do I do next?
4x and negative 10x.
Now I do those, good. What do I get there?
6x.
What was that?
Negative 6x.
Negative 6x. And then finally my 8 is all I have left. Any other like terms, or am I good?
It's good.
It's good. All good. That's my final answer. So at the end, we're not doing anything completely different or new. We're still multiplying the same way. We're distributing just as usual. It's just that since you have a binomial times a trinomial, you want to split it up just to make sure that the x is able to be distributed to everything and the 2 is able to be distributed to everything. So how do we feel about this? Give me a quick little, in general, go ahead and give me a quick little emoji. Let me know how you're feeling. Thumbs up. Are we happy? Are we scared? Are we confused? How are we feeling? Karina's head is exploding. Okay, that's a little troubling. I see a few thumbs up. Christopher's a little, what is that, shocked face? Oh, Guillermo's feeling great. That's good. That's good. That's good. Okay, so I'm definitely seeing, it's very interesting with this topic. A lot of times, the people who struggled with topic 7 do really well with topic 8. And it's just something that happens to me every single year. There's people who like weren't doing so well before, and all of a sudden like they really understand this and they feel really good about it, and that's good. But at the same time, I have the opposite experience. Sometimes people who used to do really well are just having a little bit more trouble with this. So it's kind of like people have different brains, and different brains are able to handle different things differently. So it just goes to show that life is interesting, right? But those of you who are a little bit confused, maybe a little bit, I don't know, maybe a little bit frustrated with this topic so far, the best thing that you can do is practice. And I promise you, the more you practice this, the more it's really going to just become easier and easier. And you'll stop making those same little mistakes. So that all comes down to the homework assignments and making sure that you're doing those. And if you do your homework assignment and you don't get a good grade on it, do it again. Don't just leave it there as a 25% or a 50%. No, do it again. Do it again, do it again, do it again, because that's practice. And the more you practice, the better you're going to do. So I encourage you to try anytime that you get a lower score. If you don't get 100, do it until you do. Okay. Let's do another one. And guys, we're almost done. We have like only 2 more problems. So similar idea, we'll do this one together, and then the next slide, I'll have you guys try it on your own. But similar idea, I'm just splitting it apart and then distributing partially. Now on this example, just be careful because I have a -4. So that's going to change things a little bit. So first I have my 3x, and I will distribute that to the trinomial. Then I have -4, so I'm bringing it down with the negative sign. And I'm distributing that. Okay, so let's go ahead and distribute the 3x. Nice and slow. 3x times -2x squared.
-6x to the power of 3.
Beautiful. -6x to the power of 3. 1 plus 2 gives me 3. Next one, 3x times 5x.
15x.
15x. Just x?
No, x squared.
X squared. Again, I always like to fill in those invisible ones just to remind myself. Okay, and then finally 3x times -6.
18x. No, negative 18.
-18x. Awesome. Questions on that first part? All right. Next round, same thing. But now remember, this is a -4, so be careful with those negatives. -4 times -2x squared.
Positive 8x squared.
Positive 8x squared. -4 times positive 5x.
Negative 20x.
Good. And then finally, -4 times -6.
Positive 24.
Positive 24. Okay, we've got this long, long, long polynomial. We're going to go ahead and combine like terms. Which of these should I put down first? If I'm trying to write it in standard form, who goes first?
-6x to the power of 3.
-6x to the power of 3 goes first. Cross it off. What goes next? What should I combine next?
Squares.
The squares. So 15 and 8. 15 and 8 make what?
Positive 23.
Positive 23x squared. Cross them off. What goes next?
Negative 38x.
So we've got the x's, right? -18 and -20 make -38x. Cross them off. All I'm left with is 24, my 24 at the end. There's my answer. So each part of this problem is, at this point, should feel pretty comfortable, but the most important thing is to take it slow. The worst thing you can do is try to do this in your head. That is the worst thing. And I know that a lot of you guys, you like to do things in your head, and that's fine, but I want you to train yourself and force yourself to write it down. Because as soon as you try to do this type of problem in your head, you're going to open yourself up to make a lot of silly mistakes. So writing things down, taking it slowly, don't rush through this type of problem, and just make sure that you're paying close attention to all those positives, all those negatives. There's a lot going on in this type of problem. So even though each individual part of it isn't too bad, altogether, there's a lot of room for mistakes. Questions? Yeah, Karina, like I always say that too. When you write things down, you remember them way, way more easily. And that's just like a scientific fact that when you physically write things on paper, your brain is able to remember them better than if you just look at it. So writing physically helps you out as well. Science. All right. Here's one to try out on your own. I'll give everybody about 4 minutes. Because like I said, I want you guys to take it slow. Don't rush. So 4 minutes on the clock. And I think after this, we'll pretty much be done. Go ahead. Okay, about 1 minute left. Don't forget to send me your answers in the chat because I'm replying to people and I'm letting you know if you made mistakes or if you got it right. All right. So looking pretty good. All the answers I've received have been 100% correct. So let's go ahead and go through it. Oh, I just got one more and you're good, Sophie. You got it right. All right. So splitting it up, got my 3x, got my 1, split them up. All right. And let's just go ahead and distribute. Now, since I know for a fact that everybody who sent me an answer got it right, if you know you got it right, I better see some public responses or some responses out loud. Don't just keep it on private. All right, so here we go. Nice and quick. 3x times x to the power of 3.
3x to the power of 4.
Good. 3x times 4x squared.
12x to the power of 3.
12x to the power of 3. 3x times negative 7.
Negative 21x.
Negative 21x. Awesome. Now I'm multiplying everything times 1. So that actually ends up being pretty easy because anything times 1 is just itself. So now I've got 1 times x to the power of 3 is just x to the power of 3. We just get 4x squared and we just get negative 7. So now the most, I would not challenging, but just the place where most people make mistakes is this step. So we're going to be very careful with it. What comes down first?
3x to the power of 4.
3x to the power of 4. Cross it off. What do I combine next?
12x, 3.
Good. 12x to the power of 3 and 1x to the power of 3. What do I get?
13x cubed.
13x cubed. Are there any more like terms?
No.
Nope. Don't make that mistake. I accidentally combined these when I tried it the first time, and that's because I was rushing. So there you go. Even Miss Lopez makes those silly mistakes. What comes down next?
4x cubed.
4x squared. Cross it off as you go. What goes down next? What goes next?
Negative 21x.
Negative 21x. And then our negative 7 goes last. So we end up with this super long answer. It's got 5 terms in it. It's in standard form. No more like terms. That's how you know you're done. That's how you know you're done. So any questions on this one? All right, guys. Y'all did really well today. We got through the whole lesson perfectly on time. As a reminder, there is an assignment. It's due Friday, but remember, if you actually, I don't think I went over this with this period. So really quickly, right now, go really quickly, look at your grade in the grade book. If you have an F or a D, failure notices come out tomorrow. But if you do this assignment tonight and I put it and you get 100, odds are your grade is going to go up and you're not going to have a failure notice. So do your best to get it done tonight if you want to avoid getting a failure notice tomorrow. And there's just a couple of you in this class. There's not that many, just a couple. So make sure you know your grade, make sure you know which assignments you're missing. And if you're still missing anything, get it done, try to get it done by tonight so that you don't end up with a failure notice tomorrow. Okay, and then for anyone else, if you're not worried about failure notices, it is due Friday at midnight. So as usual, try to get it done as soon as possible. Cool, y'all. Have a nice afternoon, nice day, and I will see everybody tomorrow. Thank you for a really good class.
See you tomorrow, Ms. Lopez. Have a nice day.
Thank you. Bye.